Okay guys, now we're taking everything that we've learned and we're putting it together to solve application problems using right triangle trig. Yes, that means we are doing word problems, but you already know all of the steps. The first thing that we have to do as we read the problem is draw a picture so that we can visualize it. So we've got a 14-foot ladder being used to get to the top of a 12-foot tall wall. So here's my wall. Okay, and I know this is 12 feet tall, okay? And I've got a ladder to get to the top of that. So here's me and my artistic abilities. There's my ladder, okay? My ladder is 14 feet tall. And I want to know, what angle of elevation. So the angle of elevation, remember, is from the horizontal looking up. So that's our angle of elevation that we're talking about. And here's just a simple drawing of the triangle. This is 12, this is 14, and this is theta. This is what I'm looking for. Okay, so now I'm going to label my triangle based on that. This one is opposite, this one's the hypotenuse, and this is the adjacent. So I have O and H is 12 over 14. O over H is sine. So sine of theta equals 12 over 14. You don't have to reduce on these. I'm looking for the angle. Remember, when we're looking for the angle, we have to do the inverse function. So I'm going to do inverse sine 12 over 14 equals theta. And then you're just going to enter that into your calculator. So I'm grabbing my calculator here. 12 over 14 inverse sine. And I get 58.9972. If I'm rounding even to 2 decimal places, this one is going to be 59 degrees. That's the angle that we need to put this at in order to reach the top of that wall. All right, let's look at another one. So we've got a 6-foot tall man standing 50 feet from a flagpole. So here's our man. He's 6 feet tall. And he's 50 feet from a flagpole. So here's my flagpole. Okay, when he looks at the top of the flagpole, the angle of elevation is 39. So the question I have for you is this the triangle that I'm talking about? Is this the angle that's 39 degrees? When the man is looking at the top of the flagpole, is this where he's looking from? Okay, I know some of you caught that. No, the man's eyes are not on the ground. The man's eyes are up here, and we're going to assume they're at the 6-foot height. They're not quite, but that's a lot closer than it was before. So we've got this 39-degree angle of elevation. I know this part is 50 feet. I'm looking for the height of the flagpole. That's my X. But in order to find that, I need to first find this part. So this is the X that I'm going to start with in my equation. And as I label those sides, I've got opposite and adjacent. O over A is tangent, so I'm going to use tangent of 39 equals X over 50, because x is in the numerator, I'm going to multiply 50 times tangent of 39, and that's going to give me that little pink x that I've got there. So 50 times tangent of 39 is, I'm going to double check my answer there, 40.49. Okay, so is that the height of the flagpole, 40.49? Yes or no? No, because all we found was this part right here. How do I know what this whole thing is here then? So that top x was 40.49, and this part was the height of the man, plus 6. So the flagpole is about 46 and a half feet. And we're going to round, I'm just going to round to 1 there. You just want to make sure that you're answering it the way that it's asking you. Okay, let's do another one. How about this one? A plane is flying at an altitude of 12,000. Here's where you really get to see my artistic abilities. So here is my, oops, erase that piece. Okay, here's my airplane. Yep, that's an airplane. And it's 12,000 meters high. Okay, from the pilot, maybe I drew my airplane backwards because we're going to put the airport tower. From the pilot, the angle of depression to that tower. So angle of depression would be this one. It's 32 degrees here. So if I want to use my original triangle, I'm looking at this one, 32 degrees. Or I could label this 12,000 and that would be fine too. How far is the tower from the point directly beneath the plane? So this is the side I'm looking for. So again, as I label my sides, I've got O and A. O and A is going to be tangent. So tangent of 32 equals 12,000 over x. That means x times tangent of 32 equals 12,000. That means x equals 12,000 divided by tangent of 32. And you're just going to enter that into your calculator. To save time on the video, I'm gonna move to the next one and have you draw a picture for a great white shark swimming 22 feet below sea level, and he's 67.7 feet from a sailboat, and we want to know the angle of depression from the boat to the shark. So draw that picture. Pause the video for just a second. Draw that picture, and then I'm going to draw the picture, and you'll be able to compare. So pause the video now. Okay, here's my sailboat. And I've got a shark that's over here. Yep, that's my shark. He needs a fin there. Okay, he is 67.7 feet. The distance from the shark to the sailboat is a straight line, so he is 67.7. And we want to know, oops, what is the angle of depression? So again, this is my angle of depression. In my lower triangle would be this one. And we know that the shark is 22 feet below the sea. Okay, so we've got, if I'm using this top triangle, because I have the sides all labeled already, and my angle of depression is here, opposite over hypotenuse. So O over H equals sine. So I've got sine of x or theta equals 22 over 67.7. I'm looking for x. When I'm looking for the angle, I've got to find the inverse. So inverse sine 22 over 67.7 equals x. Type that into your calculator. And you should get 18.96. So if I'm rounding to the nearest degree, I would say a 19 degrees. If not, I could say 18.96, depending on how specific I want to be. Either 18.96 or 19 degrees. That's the basics of what we're doing here. So there's several in here for you to try, but there's one more that I want to do with you. And it's actually not even one of these, but we're just going to talk about it. So I'm going to cross this out, and we're going to do our own. I just need some blank paper here. So we're not looking at what it says here or here. Okay, we're going to talk about a bird in a tree. So here's my tree. A bird in a tree. Okay, he is 8.2 feet above the ground. Okay, so here's my little Tweety bird. Let's do him in a different color so we can see him. Okay, there's my bird. He is 8.2 feet above the ground. So there's 8.2. Okay. He sees a worm. That's 13 feet from the base of the tree. So here's my 13 feet. And here's our little worm. Our question is, at what angle did the bird see the worm? What angle was his head at to be able to see that worm? So the angle that he had to look down, at what angle did the bird see the worm? Not the angle of depression. We're not talking about this. How far did he look down? We're talking about this one. Okay? So it's again tangent. O over A. Tangent of x or theta is 13 over 8.2. And you would solve that the same way as the others. The key that I wanted to point out here is that sometimes we do talk about an angle that is not the angle of elevation or not the angle of depression. And it's what angle did he have to turn a camera to, or what angle, if we said what angle did he have to look down, then it would have been angle of depression. But at what angle did he see that? It's actually this angle that's not the angle of elevation or the angle of depression. That's an important point to know as you're looking at the homework, because there are a couple of those on the homework. that don't talk about the angle of elevation or depression. They're talking about that other angle inside the triangle. All right, you got this. And this is it for this unit. We are done. Good job, guys.